Hey everyone, happy International Manufacturing Day with Prismier and VEX Robotics. Today we're linking you up with Illini VEX Robotics, the amazing college-level robotics team straight out of University of Urbana-Champaign that we proudly sponsor. We're going to be diving into some questions that were sent to us about college robotics, and our team's all geared up to answer. So without further ado, we're just going to have everybody on the team introduce themselves and their positions.
Hi, my name is Anaz Kim. I am the president of Illini VEX Robotics. I am currently a senior at U of I, and I'm majoring in brain and cognitive sciences with a minor in computer science.
Hi, I'm Praveen. I'm the vice president of IVR, and I'm a junior in CS.
Hi, my name is Abizar Kamperwala. I'm a senior studying information systems, operations, and management, and I'm the corporate director.
Hi, my name is Emily Kozlowska. I'm a junior studying accountancy and finance, and I'm currently on the corporate team running professional development.
Hi, I'm Ethan Park. I'm a senior in mechanical engineering here at U of I. I am the R&D research and development director.
Hi, I'm Dylan Edwards. I am a junior in systems engineering and design, and I'm currently the outreach director.
Hi, I'm Owen Harry. I'm a junior in industrial design, and I'm the marketing director for Illini VEX Robotics.
Hi, my name's Reed. I'm a sophomore at U of I, and I'm a computer science plus astronomy major, and I'm one of the lead programmers for Illini VEX Robotics.
Hi, my name's Kevin Silbernagel. I'm a junior in systems engineering, and I am a mechanical engineer at Illini VEX Robotics.
Yeah, your guys' majors are really cool. So to start with, does someone first want to give a very brief explanation of what VEX is in your own words?
So VEX robotics competition, it has a couple different levels, middle school, high school, and then the level we compete at, which is the university level. Due to the VEX competition, we build around 2 to 4 robots every year to compete in a game that's designed at the start of the year. So typically we compete started next year in February through the start of summer.
In the competition, there's 2 different sections that every team tends to compete in. There's one for competitive and one for skills. Each match there is a split. Like the first 45 seconds for university level is autonomous, so we do not have any control with our remote control or whatever. It's completely like fully programmed. The remaining of those 2 minutes, we have full driver control, and we use our programmed driver stick and like shoot, in like a little way, yeah, in our own way.
Okay, yeah. So I bet those remaining 2 minutes are fun. Yeah, so question for all of you. Curious about how beginners fit into the team, and how do you support people who come in who say like, I know nothing about robotics or about math or about science, or I don't even know how much math and science you use.
So for the newcomers to the team, basically we want to make sure that everyone is up to speed on like the levels of skill that is necessary, especially when it comes to CAD or computer-aided design. We've been hosting workshops so that everyone, even freshmen, can come up and be at the level where they can help contribute. I think it's important that everyone gets the chance to contribute, and I feel like without CAD experience, it's very difficult to. So in this way, we make sure that we invest a little bit in our new members, make sure that they're up to speed, and so they can help feel like they've had a meaningful contribution to the team by the end of the year.
And those CAD workshops, are those kind of built and run by the students, or how are those executed?
Yeah, so I actually played a hand in part of that workshop as well. Basically, we had some of our senior members of the club, people who've just had generally more CAD experience and had time to go through the university curriculum in terms of CAD, lead a workshop, and we basically ran them through a few different types of models that they can generate, and so taught them the skills to do that, and then had them do more like individual projects where it's more free form and they get to test out these different tools for themselves. And by doing so, it gives them the confidence to use these tools later on in the year for both the VEX robotics side of things and other departments in our club, like research and development.
There's so much. You guys have quite the setup on your team. Like, it's a team that covers like the commercial, purchasing, manufacturing aspects. It's like you're running a mini business within a larger business, which is terrific. And major kudos to the instructors and your teachers who have like made that happen too. But Could you just tell me more about how that structure has shaped your perspective and how you think it's preparing you for your career?
Well, it definitely hasn't been easy. This has been our third year as a club on campus. Each year we've been growing. The club itself is composed of 4 main sub-teams. We have a corporate sub-team, a software development sub-team, a research and design sub-team, and then the VEX sub-team. So all of these sub-teams together form Illini VEX Robotics. Each of the sub-teams respectively have their own director, as well as some various other positions which form our executive board, which is the main hierarchy which governs Illini VEX Robotics. Obviously, with so many people in the organization, there is going to need to be some structure to keep everything running smoothly. But one thing I found very appealing about this organization is how collaborative it is, and that we have many members which are parts of different sub-teams. So you may have someone on marketing who's also on the VEX team who also may be contributing to our R&D team, right? So that's been really cool.
That's terrific. That's literally living in a real life business or acting out as if you're in the real world. So I can see how those skills would translate over a lot. And I guess on that note too, alumni from your team, how do you know of like ways that they've typically leveraged their experience after graduation and ways in which you might plan to do so?
Yeah, so since we are only a 3-year-old organization, we haven't had much, but we do have some alumni that come back for like our event for Cornfield Clash. They come help and support us for that, and then as well as help us kind of connect with different companies and kind of in that aspect.
Since we are an engineering focused RSO, like a registered student organization, yeah, it's really valuable, like I said earlier, to have students from like a wide variety of majors and like interdisciplinaries and things like that. Like we have a couple of Geese College of Business students in our club helping us out with corporate marketing and like a whole bunch of other things. And like I myself, I'm the president, and I am not an engineering major, but I really have enjoyed being a part of the tech world and applying like my knowledge and skills in like neuroscience and neurotechnology, and like applying my skills here and like taking the skills I get here and outside. And I think like a lot of our members will agree about this invaluable experience.
Super impressive and cool to hear about the fact that you have people who aren't necessarily interested in engineering or robotics, but they're on the team. And like I'm glad you said that, because that was going to be a question of mine. How many people like in your team are not like experienced in robotics?
I would say it's very common. Robotics is really such a vast like industry. It's just a really big field, and like you can really apply like any of your knowledge into robotics. Like I do brain computer interfaces for fun, and like I've been in robotics since like middle school, so I really wanted to like continue being in robotics and like using both of my knowledge and skills to apply towards that. And like really most of our other students, though we do have a lot of engineering based students, a lot of other students are really here just to, you know, like do it as a hobby, or like it's their like, you know, guilty pleasure, you know.
Just a casual Tuesday, you know, doing brain whatever. I don't know what you said. Yeah, thanks. That makes a lot of sense. And the fact that you're president too, and you didn't necessarily like come in with that background is cool. It goes to show that it really is about so much more. So when working on the robotics curriculum and building your robots, it wasn't a paid project necessarily, but it sounds like you had a lot of interesting experiences, especially with supplier and customer relations. So as we look ahead and consider how important supplier relations are becoming and just how important they are, how did you navigate those connections during your project, and how does that experience shape your perspective moving forward?
So kind of how we've kind of dealt with our suppliers and kind of with people who we worked with throughout the semester during last semester during kind of the main problem times, where just kind of keeping that constant communication of knowing where everything's going and how everything's going, being very clear with our communication, and kind of giving weekly not weekly but monthly updates, and making sure everyone's on the same page and everyone knows where everyone is in the state of that process and everything like that.
Have you found any difficulties in that? Like, I know that's a pretty loaded question.
Yeah, so I think one of the main difficulties is, again, like with those monthly emails is knowing what to say and kind of knowing what to give an update of each month. But because a lot does happen over a month, but a lot of the stuff is kind of repetitive, especially in the earlier dates, and kind of knowing when things are happening. So I'd say it's kind of making sure those monthly updates are informative and kind of interesting to kind of get everyone involved.
So I wanted to ask about DFM, Design for Manufacturability. I've heard this acronym thrown around here a lot, and can you just tell me about some of the headaches that you might have gone through with that, and how you think maybe a real manufacturer could help deal with those in the real world?
Yeah, so design for manufacturing is kind of a large part of what we do at VEX Robotics. I think one of the standout parts of this for us has been sort of finding the materials that we want to use to actually fabricate our robots. A large part of this has been working with the resources that we have at the university to basically determine what tools and equipment we can use and what materials we can use with that equipment to actually make parts that are going to serve the functions that we need.
Yeah. Has that been like a tough process, or how has that process been, and has it kind of like changed throughout time?
Yeah, I think in the beginning it was definitely a bit more difficult in the sense that we just had a lot of things to juggle. We want to figure out what our robot was made of and things like that, which materials would make most sense for the project at hand. But as we talked more with people around us, whether it's in our academic institution or our industry partners, we were able to really hone in on a lot of the different things. And I think we also have Prismier to thank for part of our robot, especially like the steel plate that we had to cut out for the bottom of our robot. We would not have had the tools to actually go about doing that here at the university, but Prismier was able to help fabricate that for us, and that was a really huge help.
So glad to hear that. We're happy to ride on your guys' coattails. I wanted to ask if there have been any like memorable or humorous situations that have happened, like during competition or just when testing things out, or like the weirdest or most unexpected problem you've ever had to troubleshoot.
I guess we were trying to design gears for our drivetrain last year, and we went through like many iterations of our gears, and I'm not kidding when I say like we had buckets like full of gears that we had to go through, and this was like near the end of our competition season where like our robots needed to get done quickly, so we were like 3D printing gears like every single minute of the day, like trying them out, testing new ones. So yeah, that was like a fun experience and stressful experience of last year.
Just gearheads running all around the place. What was the time limit?
Well, for the gears, that was probably like a 2-3 day process where we were just going through gears, but probably like a month before our Worlds competition. So yeah, last season we were a little bit behind, so we had to kind of focus on getting our robots done within that month period.
I also want to chime in. This was all at the Purdue qualifiers competition. Well, since last year's season's game was pretty much disc golf, a bunch of other teams like brought like a bunch of frozen waffles that were like pretty similar in size to our like disc that we were gonna throw in, and we pretty much like spent like most of the time like flinging those frozen waffles around and like collaborating with their teams, team bonding, like socializing.
We also found out that if you toast the waffles, they went a little bit further and then they were frozen. We did a little trial and error there to see what works best.
Right. They even brought like their microwave oven.
It was a huge toaster oven they brought, and we just started making waffles.
Did they bring it like for the purpose of like making and eating waffles, or okay? Check that. Yeah.
Yeah, and then I think another part within that competition, like intake system for the flywheel, I believe, needed a little bit more friction. We were like running around, like carrying alcohol wipes and like sandpaper and just trying to like grit down the intake like before each match, and we were like racing to our like next match, and it was like really not ideal and really need to find like ways to better that process and just learn from it, but it was a good learning process.
Cool. I'm looking around and seeing like people's faces like lighting up with like recognition as you talk about it, and it's funny. Yeah, I mean that's bonding, isn't it? Like you're all closer now as a result. This is a pretty big general question, but what impact do you think that being on this team has had in finding your career?
For me, I did robotics through high school, and so going into college when I saw this club, I thought it'd be fun to try robotics again in college, although I kind of want to take a different route. So my freshman year, I did pretty similar tasks where I was doing like a lot of mechanical stuff, which is what I did in high school. But after my freshman year, I tried to like scope out to the different areas of robotics. So for example, my sophomore year, I did a lot more of the programming side and the software side. And this year, as a junior, I'm doing more of like the engineering manager side. So managing people, trying to get projects up and running, and that like management side. So getting the experience of like all the different things that are involved in like engineering as a career has been like a helpful experience for me. Moving forward from like career path, I can definitely see like the pros and cons. So as I like move into senior year next year and then think about like a career, like these are things that I'm like taking into like consideration. So like me personally, I never thought that I would like the engineering management side, but turns out like it's been really fun like managing people, working with people, and like developing projects and developing people. So yeah.
Yeah, I think I want to add another perspective to this. I joined the team last year through VEX Robotics. It was just a nice opportunity for me to meet a bunch of other people that are also passionate about robotics. And now as a senior, I moved more towards the research and development side as the R&D director. And so through this, I've had the really unique opportunity of leading a group of underclassmen and just trying to work on a research project headed by one of the professors here on campus. And it's really pushed me. I think my career path was always going to be going into a PhD and then going into prosthetics after that. So the robotics part of like biointegration. And I think this R&D and also the VEX-U part of things has really made it clear to me that I just enjoy being with other people, going through the robotics processes, and really makes me hopeful for my PhD program as I go and look to do more research.
Yeah, awesome on both those ends. And on the fact that it's people oriented too. I think that's one thing that like a lot of people might not immediately think of, at least not me, but you realize pretty quickly like how interactive it is and how social the sport is. It's a sport, right? Robotics is a sport. Yeah, yeah, you would say it's a sport. On a robotics team, do you really use like math, science, like topics like that?
So I can take that question. Well, I'm on the programming side of things, and we definitely do use a lot of math and science in programming. So there's the math aspect. We have to do a lot of math to configure all the drive trains the mechanical team comes up with, as well as doing things like calculating the RPM for, say, we need to spin a motor at in order to shoot the disc from last year into the goal, or things like that. And also from the science perspective, yeah, so for programming, we definitely do use a lot of math and science and additionally physics.
As we said, Illini VEX Robotics is a very multidisciplinary organization. We have people from many different backgrounds, and of course we sort of utilize skills from these different disciplines. So depending on whether you're from, like a mechanical engineering or a computer science background, there's plenty of different things to do. I guess Dylan, do you want to?
Yeah, another thing, so specifically regarding like material science, we do a lot of stress and strain on the parts that we create, whether it's the 3D prints or any type of bracing. We make sure that everything is like structurally sound and will not like fall apart with any sort of impact that occurs during the competitions.
That's really, really cool to me. I think that scares a lot of people off, but the fact that you can just dive right in is great. Sorry, to double check on that takes like those mechanisms too, like the math and science mechanisms in order to do that. Would you be able to explain like how that would work?
Yeah, so like the 3D printed parts that we have, we use plastic filament, and when that's printed onto each other, on each layer, it's very, very strong. So when you pull on each layer, it's a solid plastic piece. But when those layers are adhered to each other through heat, those pieces are weaker. So even though it's a faster process overall to 3D print and it has a very fast turnaround time, sometimes for pieces on the actual robot, we would prefer to go with something like acrylic, Delrin, both of these being like different sheet materials that we can laser cut. And if we get chunks of Delrin, then we can actually CNC or like just 3D model using that, where it's a process where we take away from a larger chunk rather than an additive process like 3D printing. And things like metals and other materials are typically harder to manufacture just because they're stronger. And we would be relying on different organizations outside of our own to actually incorporate those into our robot.
Thank you. I know you guys have been looking for Delrin, so. Well, with that being said, thank you so much for your time today. Thank you for joining Prismier and VEX Robotics for Manufacturing Day. This has been a lot of fun. I know that I learned a lot and expect more in the coming future. I think that we'll be doing a lot more with these guys.
We, as the Illini VEX Robotics team, want to thank you guys, Prismier, for being such a great sponsor for us, taking care of us, giving us a lot of materials that we can work with. It's really helping us with our with growing our education and promoting it to other students of ours. So we'd really like to thank you guys.
So it's very kind. I know for a fact, just everybody who I've talked to at Prismier, just very honored to be able to support a group of such vibrant and curious and hungry minds. Like you guys are all just clearly very passionate, very impressive group of individuals, very put together, and we're just happy to be able to support that in any way which way possible. So no, I appreciate that, and we want to thank you guys.
Yeah,
I think we're chilling. I think we're good. I'm trying to think of like how one would end this.
Do you want like a clip of all of us saying Happy Manufacturing Day?
They're grabbing the trophies that Prismier made for us for Cornfield Clash last year.
Awesome.
They turned out awesome. We got so much positive feedback on that. That was really cool.
I think I'll be attending the Cornfield Clash. Hopefully some of us will be coming this year. It'll be fun.
Awesome. Looking forward to it.
Same. It'll be
Happy
Manufacturing Day. Happy International Manufacturing Day.
Happy International Manufacturing Day.